YouTube channel.
Alright, so everyone make sure you guys are getting your notebooks out. Look at the number, it's on the projector, and start working on that. 3 minutes for this.
I don't know. The coach took me up for the last few plays because he thought that I was getting a concussion. Just because I was fucking dizzy.
Did the twins play?
Huh?
Right now.
So, the twins? Yeah. Both of them.
Which one?
Both of them.
Both of them?
Yeah.
He was right. It was like I haven't been in practice so long, and it was like, what about having big players so they'll play no matter what?
You know, my dad's gonna make me drop out of the class just because the parents are too small. It's kind of dumb.
Make sure you guys are getting your notebooks out too.
I got it.
Hi, Adrian. So, just do it like this.
Oh, that drawing is due tomorrow. I just got hungry.
Why are you being recorded?
So, make sure you guys are doing this, okay?
My ass should be here.
All right, 1 more minute. 1 more minute for bell work.
Do you have them?
You guys sign up the wait sheet, please.
Don't need like a sheet.
What?
Don't need
All right. So everyone, if for the people that just came in, make sure you guys get your notebooks out and look at the projector. We have about 30 seconds left for this bell work. 30 seconds left. All right, so that's time's up. Time's up for that. So for this bell work question, where do plants get matter? Mohammed, where do plants get matter? Not sure? Adam, what do you think? Does any volunteers for where plants get matter? Stefan?
Field 2 and what?
Yeah, perfect. CO2 and water, right? Yeah, plants get their matter from carbon dioxide and water. So make sure you guys know that. We're gonna go into a little bit more of that today with this objective, okay? So Nestor, can you read the objective, please? Yeah.
Create models of the photosynthesis equation in order to understand how plants make their own food.
Yeah, so basically, you guys see that, those envelopes on your tables, we're gonna use them in a little bit. There's some things inside them that we're gonna use to make models of the photosynthesis equation, okay? So that's gonna be our objective for the day. But first things first, we're gonna watch a quick video, and then we're going to do some notes on our notebooks, okay? On page 36. Borrow a pencil? Yeah, sure. All right. I'm gonna turn the sound on real quick. So, all right, well, I have to go look at the other video.
Oh, you have
All right, so I want to make sure you guys are looking at the video. It's gonna have some important info on it, so make sure you guys are paying attention.
Mountains here. So the numbers do matter. Then there's another factor, and if you stop and think a little bit about it, you'll probably remember that chemistry does point out that these atoms have some weight. We've got atomic numbers here. For instance, even for carbon here, atomic weight of 12. And you could figure out what a carbon dioxide molecule would weigh. So altogether, you've got all these molecules, and when we put them together, we can get something that does have some mass to it or weight that we can recognize as a tree. Looking at photosynthesis here as an equation that you are familiar with, 6 water molecules, 6 carbon dioxide in the presence of light produces this molecule of glucose with 6 oxygen molecules left over. And when you stop and think about it, this glucose molecule here can be used in the plant, and shown in this diagram over here, in 3 different ways. This is a glucose molecule I've shown here built out of Lego, but we'll get back to that a little bit later. Right now, the glucose molecule could be used either for energy, or it could be made into a very long chain, like here, this molecule of starch, which is stored in the plant in places in the roots, such as potatoes, or it could also be stored in seeds and fruits. And then the third way a plant could use its glucose is actually to make its own structure. And this is a molecule of cellulose, which is more chains of glucose, chain of glucose put together. And this structure is what I showed you originally when we started off. This tree that's here, this trunk, has a lot of cellulose in it. And the other example I brought just to show right now, to remind you also that roots can also store a lot of glucose as starch, right here. Now, talking about starch and cellulose, I'd like to point out that they're all made of glucose molecules, but interestingly, they're put together in different ways. So, for example, if this was a glucose molecule, and this was a second glucose molecule, starch would look like this. It'd be a long chain of regular molecules of glucose put together. However, cellulose is different, still glucose, but the second in the chain is added upside down like this, and the whole chain continues in a long fashion, alternating glucose molecules. So the connection here is really very important. In starch, what I've got here, our bodies, our human bodies, can digest this, but our bodies cannot digest the bond that is like this. We cannot break this one. Luckily, there are critters out there that do know how to digest cellulose. Those are bacteria, and bacteria can be found in cows and help them get some energy out of the long cellulose molecules that are in grass. So we've talked a little bit about cellulose and starch and how they started off originally as being made from glucose. And we'd like to now stop and think a little bit more about the chemical reaction itself. And I'm going to suggest that we do an activity and talk to you a little bit more about those details next. Okay, before you start this activity, I just want to point out something about the carbon dioxide. The carbon dioxide actually enters the plant on the underside of the leaf. And you can't see these small openings, but the picture back here does indicate that the carbon dioxide is coming through those openings that are called stomata. So carbon dioxide is going to be modeled in our activity here, and we're going to model it with these bricks. If you don't have bricks, you can also use small papers, but I'd like to let you know that the bricks that we have here, each one represents an atom. And the atoms that they represent are over here. We have carbon as being black. These are the regular chemistry colors. The hydrogen is being white, and the oxygen is being red. So if you're going to make a compound like water here, you can easily join them together. That's one of the nice things about the bricks. They can be easily combined, just like atoms can. So coming back to the equation here, you can see that you can actually model the entire equation through using bricks. But what I'd like for you to do is to do it stepwise, pretty much the way the plant would do it. So I'd like for you first to start off with obtaining 6 water molecules, maybe make and build them here, laid out on a piece of paper. And then what you do next would be to make the 6 carbon dioxide molecules. And then what I'd like for you to do is to only use these atoms to do what the plant does, is to put them together to make 1 molecule of glucose that's over here with these 6 oxygen molecules left over. Now the glucose is a rather difficult looking structure.
Okay, so that's all of this video that we're going to watch, but basically we're going to take some notes about that real quick. Isaiah, can you sign the late sheet, please? And just take out your notebook. So, everyone turn to page 30 of your notebook, and just copy down this equation, okay? It's the same equation that the lady just showed us. So I'll zoom in a little bit if it's hard for you to see. Just send it over. And then take out your notebook and turn to page 30. Okay, so most of you guys should have this copied down. So here we have, this is the photosynthesis equation. Okay, the photosynthesis equation. So this is basically exactly what's happening in photosynthesis. So here we have H2O, right? H2O. What do you guys think H2O is?
Water.
Water, right? So this is just water. I'm going to label that water. And then CO2, what does CO2, it's kind of blurry, yeah, but what does CO2 stand for? Carbon dioxide, right? Carbon dioxide. And then we're gonna skip this one real quick. But what is this one? O2. What is O2? Oxygen, right? It's just oxygen. And then I don't know if you caught it, but that one lady in the video, she said what this one was. Do you guys know what this is? She mentioned it once, I think, or twice. So it's another word for sugar. You guys remember it? Okay. So it's okay if not, but this is going to be a really important thing. Okay, so make sure you guys remember this. But this C6H12O6, this is what you call glucose. Okay, glucose. Glucose is a type of sugar. Okay, glucose is a type of sugar. Just like what the lady was saying, this is what plants make. This is what their actual food is, okay? This is what their food is. And they can sometimes build it into other types of food, like the starch. So that's what like potatoes are. And sometimes it can also use it to make its own structure. Like, example, the roots and the leaves, stuff like that. They still make all that out of this. This is the building block for everything. So on the left side, all of these things, right? This is what we call the reactants. This is what reacts with one another. Reactants. And then this side, the right side, are the things that's being made. Okay, there's the things that are being made. So these are called the products. Products. So now you guys know every single part that goes into photosynthesis. Oh, actually, there's one more important part that I forgot to mention. My bad. But you can just slip it in right here. I'm just going to draw a sun. So the sun is what drives this reaction. It's the energy that drives photosynthesis. Just sign up the lay sheet, please. So this is the primary focus, right? So it's basically water. Okay, so to just read it like in a simpler way, water and carbon dioxide with sunlight make glucose, which is important for the plants to make their own food, and oxygen, which is important for pretty much everything else, right? So now you guys have these notes, now you guys have the parts of every single thing, so make sure you keep that. I'm gonna also talk about one thing that I think is important. So I'm going to draw a plant right here at the bottom, okay? Like a little plant. And then it has like maybe a leaf right here. And another leaf right here. So this is not a great plant. But just so that it makes a little bit more sense for you guys, the plants, they get the carbon dioxide from these little openings on the bottom of the leaf. Okay? So CO2 goes in here. These little openings are called stomata. S-T-O-M-A-T-A. Stomata. So yes, it is a little bit confusing to think about at first because plants, they're pretty solid, right? The leaves don't really have any visible openings, but they do actually have some openings on the bottom of their leaves, and the carbon dioxide can enter through there. So this is pretty much all the notes we're gonna do for now. We might do a little bit more tomorrow, but I wanna get started on this activity, okay? So you guys should all have, actually, Nestor, Alexander, can you guys move to pink table over there? Because I just wanna have like more complete groups. So, I'm gonna put the PowerPoint back up real quick. So, in these envelopes, you guys are gonna see little pieces of red. You guys are gonna see little pieces of black and white. Okay, and a bunch of paper clips I just put in there. You guys should also have an instruction sheet. And you're going to use the instruction sheet to model the photosynthesis equation, okay? So, Stephen, Margo, you guys put your head up, please. All right. So, at your tables, you guys can pick. I'm going to let you have some freedom, but you guys are going to have a builder. So the builder is the guy that actually puts the paper atoms together. The instructions leader, the person in charge of the instructions, and the materials manager, so the person in charge of the envelope, okay? So if you have 4 people in your group, you can have 2 builders, okay? Obviously, you guys should work together and share materials, but this is what each person should be primarily in charge of, okay? So, like I said, builder, instructions leader, and materials manager. You guys can use the big whiteboards to like put your things on. It might make it a little bit easier. But yeah, if you need any help, just let me know. But we're gonna do this for the next 25 minutes. So, like what the lady said, right? Everyone just make the left side first, okay? Everyone, listen up, please.
I'm not good at that.
So this, you're gonna make this side first. 6 H2O plus 6 CO2. That's what you're gonna make first. And then after you make this, you transform all those things into these, okay? So start with this.
What if you beat
Exactly like that. That's how it looks in the back. Okay, guys. So you see?
He's on the voice with it.
We gotta make all of them.
So no, you just make the left side first.
I got it.
So the instructions that I gave you guys, this is just for building the glucose, this big thing right here. But the first part, the reactants, you're gonna make right here, okay? So just to clarify things a little bit, maybe it'll make it a little easier. So everyone look at the projector, please. Monica, Destiny, please. So when it says H2O, right, it's saying there's 2 hydrogens and 1 oxygen. So that's exactly what this is. 2 hydrogens, 1 oxygen. And you have 6 of them. That's what the coefficient is, right here. Okay? Here, CO2, you have 1 carbon and 2 oxygens. So 1 carbon, 1 black one, and then 2 red ones. And you're gonna have 6 of these also. So that's the first thing that you guys are gonna do, right? Don't worry about this part yet. Just do this part first.
says, is this picture? Yeah, how you supposed to do it?
It works. I tried it last time.
Yo, I just got a confession.
Let's have a look. We do that one for this one. We did this one.
So you only do the left side.
I got top
You're
three.
just doing the left side.
The athlete trainer.
No, you're not even doing that part yet.
If I'm
All you're doing is this.
Oh, so we just look like that.
You're doing this. This left side, okay? You're doing the right side after.
I'm doing the black.
You need to remember. You need to.
That's not the game yesterday.
Nice.
That day.
So those are the CO2s? Nice. Yeah, good. That's fine. Yeah, so that's a H2O, so that's a water molecule, and that's a CO2, so that's a carbon dioxide molecule. So just make 5 more of each. Yeah.
You see, my whole arm is sore.
You don't have enough paper clips? If you need more paper clips, just let me know. I have a few more.
Does it matter?
Does it?
No, it doesn't matter.
And then,
Yeah, at this point, it doesn't really matter. It might matter more when you're making the glucose, but that's fine. So
I'm starting the other one
you
already.
just need one more hydrogen molecule.
Oh shit, I used
So hydrogen atom. So if you put no, so this one's fine. This is what a carbon dioxide is. Okay. Oh, hydrogen. So that's a carbon dioxide. Okay.
That's what I'm saying. We did 2 or 1.
You don't have to. But that needs one more of these. Make it look like that. Yeah. Just copy what's on the board right now, please.
Okay, next song. Baby, and that baby.
It's not that big.
You know,
Oh, 21, yeah.
Nice. So you guys are starting water molecules. Okay. Yeah. So remember, this is water. Okay.
I have no more.
Yeah. So it. You more paper clips? Okay. Yeah. I'll get you more paper clips.
these ones have that. Huh?
Also, you do 6 total. Yeah, so you guys need one more. So you just need one more, yeah. So, that's the, what those are, that instruction sheet. So it takes you step by step on how to make it. Yeah. Yeah, no, I tried it last night, and it's definitely doable, but it's kind of confusing. It's just, you have to really pay attention to the instructions. You don't have to read everything, you can kind of just look at it. Yeah.
Are you able to do that?
Yeah. It's doable.
Oh shit.
Wait, remember this is water, right? H2O, and this is carbon dioxide. Yeah.
We need more paper clips.
Yeah. More paper clips?
Oh dog.
I'll give you a bunch. Hopefully that's enough. Let me know if you need more.
Okay.
For these, at this point, it doesn't matter. Yeah, as long as you can keep it together, that's fine. But when you're making the really big piece, that one, it might matter more how many paper clips. Right now.
You think we might need water? But it's all good.
The oxygen is 2, but you don't make the oxygen yet. Yeah, you're not quite there. So what are these pieces? You guys know?
Pressure hits hard, huh?
That's where that's the oxygen.
Oh, this is carbon dioxide. Yeah, this is carbon dioxide. And then these, what are these?
That's water.
That's water, right? Exactly. So remember, we're doing two part of the photosynthesis equation, so there's water and carbon dioxide. Yeah.
Why did you only go?
Okay, so I see that a lot of you guys are starting to finish up with the left side. So once you finished up making the left side, once you started making finishing up with this side, you guys are going to use these sheets to make this, okay? And you're going to try and make this out of what you've already done here, okay? So basically, you're going to have to take apart a few of the things that you've already made, and you're going to use those things, those materials, to make this, okay? So there's a couple of extra papers and stuff, but don't use the extra papers. Just use the ones that you've already used to make the reactant side, okay? So, for example, if I'm making this piece, I would be taking it out of this one, okay? Yeah, so now you're doing this. So that really big piece, it looks intimidating at first, but all you really have to do is you start with just this, okay? You see how it's just like a ring, 1, 2, 3, 4, 5 of the black ones, and then one red one. And then you just add stuff like this.
Instead of like pulling it up, just go like. Yeah, but if you pull up, it tilts that way. That way. Pull up to the side, just go like.
Just make it a chain out.
Should I make it shorter or longer?
Step 1. Alright. I'm guessing beige is white. What's brown?
You know we're supposed to be those to the black. Those.
Here's not the white. Can you do that?
Orange is red.
Isn't the white the other side?
Okay. So,
Maybe you can do it like this. Put it together.
So are you guys making the ring structure now? Okay. So
what?
I recommend actually, so that's good that you're already starting with the hydrogen,
Maybe get
but you can also start with just this. Okay, so it's 1, 2, 3, 4, 5 of the black ones, carbon, and then one red one, the oxygen. You can start with that, and it shows you where exactly that's at.
You can't do it with a sheet of metal.
So if you're part is a little bit difficult.
Bet.
You can start with this if you need to. Okay. So it's just 1, 2, 3, 4, 5. Black ones, carbon, then 1 red. And then you make a ring out of that. And then it just shows you where to add things. More paper clips? Yeah. So for everyone who's having trouble with the ring structure, just make sure you're starting at step 1 and it's showing you that you're using 1, 2, 3, 4, 5 carbons and then 1 oxygen. Yeah, so you're gonna add those things in later. So like, you made that, right? Yeah. So that goes in, like all these pieces here. Yeah. It's if you look at it step by step, it's actually not that bad. It's like you did the ring, you add some white pieces, then you add this piece that you already made, and then you add just more pieces. It's like it looks. Those you're gonna have to take apart so that you can have yeah. You guys working on the ring structure now?
Yeah.
So make sure you guys are starting with this, okay? This stuff right here. Yeah, okay.
Looks like the size of a water.
What closest notebook is?
Just the pins.
Yeah, that's solid. That's a really good start.
Just right.
So you're starting on the ring structure? Okay. If you're just looking at it, it might be harder, but if you just start with this ring, it's easier. Yeah, so if you start with this, it's a little easier.
Was white supposed to be in this? Yeah, because we don't have the beige.
Yeah?
Is the brown like a black or like a
The brown is supposed to be black, yeah. This one? Yeah, that's black. It looks a little different than the pieces I used, but these are black carbon pieces, and these tan ones are just white hydrogen.
Guess you could say these pieces were a little bit too bigger than we expected.
You have the one that line? The red line is right there. And there's nothing right there.
Blue
You
clothes,
say it goes right there.
where does these where name from?
They take all of them. They take all of them.
The white doesn't go. You did it backwards.
I didn't do that.
Oh my god.
Yes.
sure everything involved with it.
You good at it? Put on the working glass. Done.
You did it.
Yeah. Yeah. So, look at the instructions. That helps a lot. If you start with just this, it'll show you where exactly you're supposed to
I used reds instead of blacks.
Not the instructions.
No.
But it's easy to switch them out.
Yeah, that's good. That's all. I think you need one more to put these together, yeah. Solid. Wait, huh? Yeah, I know, it is a little too big, but,
Dang it, Carl.
What did you guys call it?
Okay, I did the top. I did the top.
yeah.
Yeah, just get the black one. Why does it do that? They don't add up.
Are we finished?
All right.
Last piece.
I'll make the search.
All right, so if we don't finish today, we're gonna have more time to do it tomorrow. But just keep working for now, so you know where to get to for tomorrow. Oh dang, you're making good progress. You're almost done. Yeah.
What?
Yeah, if I had to about the smaller ones, it would have been easier. That's good.
Nice.
Okay, so that's glucose. Okay, so this is the sugar, right, that plants make with the carbon dioxide and the water. So this is basically what they like eat. Yeah. And it's like, I don't know if you mentioned it briefly, but like it makes like millions of these when it does photosynthesis. And like when they make millions, they can like link it together in different ways. And that's how it makes like leaves, the root, you know. It's like super, super small, you can't see it, but eventually it just comes together and makes something that you can see. So last thing, just think about what's left over. Okay. All right. So yeah, the leftovers are awesome. right, so at this point in time, you guys try and start taking some things apart. We're going to continue making the glucose tomorrow. What? Yeah, I thought that it would be, I didn't give you guys enough time. Yeah. Yeah, you're close. There's just one more part here. Yeah. No, but this is good. Like, the thing is, once you're in here, you can probably make it again like pretty quick. No, it's a. Yeah. This is a glucose molecule. So put all the stuff back in the envelope.
What? Yay. Give me all the paper gliding questions. We need smaller cameras.
Just dump everything back into the envelope. Yeah, I said you guys were making good progress. I didn't give you guys enough time to actually.
You're lying. I didn't give him my
Oh, it's for like last time we got you. Yeah, so she also wants to do the just make sure you're worried about the sticky notes there.
Do we give this to the
What? Yeah, so you guys should have sticky notes at your tables. So just pass this out. Give one to every person.
Now he's going to ask us a question. Start exiting.
All right, so before you guys start on the sticky note, I just want to like wrap everything up. So remember, the water, these are waters, right? And this is carbon dioxide, okay? And these are the reactants. The products, okay, are oxygen, right? And glucose. So this is basically what plants use for energy, okay? This is what they use for their energy, for their structure. They can link it in different ways. So like they make like 1 million of these, right? Let's say they make 1 million of these and they can link it up in different ways. That's how they can make potatoes, roots, leaves, their stem, all those things, flowers, start off with this, okay? And they link it in different ways. And then obviously we know that plants make oxygen, right? That's good for us. That's why like whenever the Amazon rainforest or whatever is like on fire, everyone's worried, right? Because maybe the world won't have enough oxygen. So this just kind of wraps up the objective for the day. We have our objective originally was to make models of the photosynthesis equation, and we did that. Some people didn't complete this completely, but we'll get to it tomorrow. But now I just want you guys to answer one question on your sticky notes. So the question is, what are the products of photosynthesis? And why are they important for plants and other life? And then once you're done with answering this question, as you guys are walking out when the bell rings, you can stamp them on the need help and comfortable signs over there.
We just put our name.
Yeah. So I'm gonna keep you guys for an extra like 20 seconds. The bell's gonna ring soon, but just write down the answers. right, whenever you finish your answer and you stick it on, you can go ahead and go.
Oh, yeah. Where do we? Where do we go? You didn't even know when you put it there. You should even put my dick on it. I would look dumb.
Did you finish? What? The thing? No. I did. He did? Mm-hmm. The fuck? You're gonna break the camera. I don't know.